The biggest something is nothing? Have you ever looked up at the night sky and felt small? We see a blanket of stars, galaxies, nebulae. We think of the universe as being full of stuff, full of light, matter, energy. But what if I told you the biggest, most dominant structures in the entire cosmos aren't things at all? What if they are, in fact, the opposite of things? The most colossal features of our universe are gigantic, sprawling patches of almost complete and utter emptiness. It's a cosmic paradox that challenges everything we think we know about where we live. The universe isn't just what we see, it's also defined by what we don't. This isn't just a little gap between stars. Let's get one thing straight. When we say a cosmic void is empty, we don't mean it's a perfect vacuum. It's not a complete absence of everything. Think of it more like the most remote, desolate desert on Earth, but on a scale that dwarfs our entire planet. If the Sahara had 1 grain of sand every square mile, that would be crowded compared to a cosmic void. These voids do contain some matter, a few stray particles of gas, some dark matter, maybe even lone galaxies. They are incredibly underdense, roughly 1/10 the matter of an average region. To put it in perspective, imagine the universe as a giant block of Swiss cheese. The cheese is where galaxies live, the holes are the voids. We live in the cheesy part, on a tiny speck within a filament, but the holes take up most of the volume. They are the dominant feature. Picture a city at night with bright clusters separated by vast stretches of dark countryside. The cosmic voids are those dark countrysides, stretching for hundreds of millions of light years. Their defining characteristic is what they lack. When astronomers talk about size, we tend to throw around big numbers. But the scale of cosmic voids is truly in a class of its own. It breaks the brain. The average void is about 100 million light-years across. Our Milky Way is roughly 100,000 light-years across. Line up 1,000 Milky Ways end to end. They would just barely span a typical void. The largest confirmed void discovered is the Boots Void, sometimes called the Great Nothing. It was discovered in 1981. The Boots Void is nearly 330 million light-years in diameter. If you put its center where the Milky Way is, its edge would reach almost halfway to the Coma supercluster. Our galactic neighborhood would be just a tiny, insignificant dot in the center of this colossal emptiness. Even at the speed of light, it would take 330 million years to cross it. To put that in perspective, modern humans approximately 300,000 years, dinosaurs died out approximately 65 million years. Crossing a void dwarfs those timescales. And yet the Booties Void may not be the biggest. The Eridanus supervoid linked to the mysterious CMB cold spot could be over 1 billion light-years across. 1 billion, a structure that large strains our standard models. The discovery of cosmic voids wasn't a planned eureka moment, it was a slow, creeping realization. In the late 1970s, astronomers began mapping the universe in 3 dimensions. They patiently measured distances to galaxies, one by one, to build the first maps. They expected a fairly uniform distribution. Instead, they found something shocking. They pointed telescopes at the Boots region and kept finding nothing. Robert Kirshner, Augustus Oemler Jr., Paul Schechter, Stephen Schechtman. They plotted data and found a void. At first they thought the equipment was broken. They checked, they rechecked, but every observation showed the same result, a profound lack of galaxies. In 1981, they published their findings, announcing a hole in the universe. The name stuck. The Boots Void, the Great Nothing. This transformed cosmology from a science of averages to a science of structures, revealing a cosmic skeleton. Immense filaments and walls of galaxies surround even more immense voids. It was like discovering continents and oceans on a planet we thought uniform. So why are scientists obsessed with these giant pockets of nothing? Voids aren't just empty, they're pristine cosmic laboratories. Because they're underdense, regions inside voids evolve in slow motion. Dark energy, the force driving accelerated expansion, is more dominant in empty realms and easier to study there. Studying void patterns is like reading a fossilized record of the infant universe, massively magnified. One of the biggest mysteries is the cold spot in the CMB, an unusually cold patch in the afterglow of the Big Bang. A massive supervoid between us and the CMB could make the CMB look colder. Light loses energy crossing such a void, the integrated Sachs-Wolf effect. Voids define the boundaries of our home. The Laniakea supercluster sits in a gravitational basin bordered by neighboring voids. By mapping voids, we map the invisible architecture that shaped our galaxy's past, present, and future. When structures are this big and mysterious, wild ideas emerge. and that's healthy for science. One theory, voids could be evidence of other universes. In eternal inflation, bubble universes might leave scars on our cosmos. A collision could leave a circular bruise on the CMB. Some speculate the cold spot is such a scar. Other ideas link voids to the nature of dark matter. Warm dark matter could smooth out small structures, creating larger voids than expected. The few galaxies inside voids are often smaller, bluer, less evolved. Cosmic hermits developing in isolation. Even the light that crosses voids tells a story. Tiny energy shifts that help probe dark energy and cosmic history. The precise shape and emptiness of voids could help unmask dark matter and test our cosmological models. Cosmic voids are more than empty spaces, they are time capsules. Because changes happen slowly inside them, they are close to a pristine sample of the early universe. The gas and dark matter inside a void have been stretched and diluted, unprocessed by repeated star formation and mergers. Studying faint wisps of hydrogen in voids gives us a glimpse of the primordial material that formed the first galaxies. Our Lambda CDM model makes specific predictions for void counts, sizes, and emptiness. Observations are a stress test for theory. If voids are bigger or emptier than predicted, we may need to rethink gravity or dark energy. Voids are the ultimate stress test. Windows into the universe's first moments and its likely fate. When we look into the heart of a cosmic void, we confront the universe in its most elemental state. It's humbling. The bright, beautiful, complex world we inhabit is the exception, not the rule. On one tiny speck of rock orbiting one ordinary star in one of 100 billion galaxies, a collection of atoms woke up. That collection is us. We are the universe made conscious. We have the responsibility to look out at the vastness and try to understand it. Every new telescope and probe answers the call to explore. We extend our senses into the unknown. Looking up at the cosmos is a reminder of what we all share, a home on a tiny planet in a vast universe. The atoms in our bodies were forged in stars that are now part of this cosmic web. We are literally stardust contemplating the voids. So when you feel overwhelmed, step outside, look up, and remember, the universe is calling. Are you listening? The journey into cosmic voids is a journey to the edge of human knowledge. We have barely scratched the surface. These great nothings challenge our models, inspire new theories, and remind us there is always more to discover. What is dark energy? What is dark matter? Are there other universes? The clues might be lurking in the silent darkness of the next void we map. This is the shared adventure of humanity. It connects us to ancestors and to future generations. Share this story. Talk about it with friends and family. Teach the next generation to be curious. Visit a planetarium, read a book, watch a documentary. Go outside on a clear night and just look up. Keep looking up. The universe's web of light and dark has produced minds capable of appreciating that pattern. That connection between the cosmos and our minds is the most wonderful thing. Stay curious. Never stop asking questions. Be part of the legacy of exploration. If you enjoyed this journey into the largest nothing, subscribe for more cosmic stories. Like, share, and tell a friend. Keep looking up.